relationship set? Yes, come up and give me the answer. What is relationship set? Text me the message, or you can text me the message. Yes, no one? Roll number 18, Archana. Unmute yourself. Roll number 18, Archana. Are you there? Who will tell me about the relationship set? What's that? A relationship is used to describe the relationship between the entities. A relationship type represents the association between the entity. You know already the entity. Entity is the nothing but the object, things. To represent the relationship set, we are using the diamond in the ER model. Okay. Then the degree of relationship set is nothing but the number of different entity sets participating in a relationship. Set is called a degree of relationship set. It may be unary relationship if one entity is going to participate in a relationship, then it's called as the unary. If two, then it's called as a binary. When there are two entities sets participating in a relation, then it's called as a binary relationship. And more than two, then it's called as the n-ray relationship. When there are n entities set participating in a relation, then it's called the n-ray relationship. Okay. After that, we saw the cardinality, mapping cardinality. Constraints are the nothing but the rules and regulations. So any relations in the AR diagram, in the one of them, that is the one to many, many to one, or many to many. Okay. Then we can represent the cardinalities in this way in the ER diagram. If it is a one to one, then in between entity, there is a relationship which is represented by the diamond and connected to the lines. And if it is a one to one, we are on line, we are writing one at left hand side as well as the right hand side too. One to many, if it is a then we are writing one at if it is one to many, then at left hand side we are writing 1 and right hand side we are writing n. For many to 1, n at left hand side, that represent more than 1, more, as well as the right hand side 1, and many to many 1 for that n to n. Draw these diagrams. Now come to the next point, participation constraint. Participation constraint. Constraints means we already saw these are the rules and regulations. The according to the entity, each and every participations, we are categorize it into the two parts. That is the total participation and partial participations. If each and every entity is involved in the relationship, now listen carefully. Each and each entity from the entity set is involved in the relationship, then it's called as a total participation, and it is represented by a double lines. Okay, that participation is called total when each and every entity is involved in a relationship. See over here, A and B diagram, it's represent a one-to-one relationship. But at A side, A set, in that A4 is not participating with a B. There is a no relation. So is it the total? No. It's a partial because here each and every entity is not involved. Okay. And the partial participation is not all entities are involved in the relationship. That is called the partial participation in, and it is represented by the single lines. Total participation is represented by the double lines, and each entity is involved in that relationship. And suppose all entities are not involved, they involve partially, then it's called as a partial participation. Okay, hope so it's clear with all of you. Let's see this concept with an example. Yes, total participation of an entity set represent that each entity in entity set must have at least one relationship in a relationship set. So, for example, in the below diagram, each college must have at least one associated students. Each college has at least one associated students. So that's why it is represented as a total participation. Student study in and college. First, here students and college are the entities, and what's the relation between them? Study in. Okay. So each and every students may or may not study in the specific college, but college, the college must have at least one associated student. Okay, so that's why it's represented by the double line, that is the total participation. Okay, is that clear? Yes.
Yes, ma'am.
Thanks for the reply. Now move to the next slide, that is the ER diagrams. Yes, We discussed different ways of designing entities, their symbolic representation, what is relationship, what is entity, entity sets, as well as the attributes. Yes. Huh? So we understood the various design shapes too. Hmm. For which purpose we are designing particular designing shape. For a oval represent what? It represent the attributes. Rectangle represents the um, entity, okay, and relationship represented by the diamond, okay. Now all data is now collected with us for diagram to draw the diagrams. But how to create an diagram? So these are the general steps. These are the general steps. First, determine the entities. First of all, determines the entity from the given problems. Yes, customer, end users, Navy users come with their requirements to the organizations. Huh? We first of all listen that in requirements, huh? And determines the entity. How we can going to determine these entity? First of all, find out the uh, important nouns from the given statement, requirement statements. That is nothing but the determine the entities, and according to that entities as well as the customer requirements, adds the attributes. Attributes are nothing but the properties of that entities, okay. Students have attributes: roll number, name, address. Hmm. Employee has the attributes like employee ID, name, address, salary, account details, like that. Huh? Then, then identify the relationship. What's the association between the two entities? Identify that and complete the diagram. These are the general steps, okay? Is there any doubt? Let's see with an example. Here, the customer came with his requirement. Hmm. Here we are drawing the ER diagram for a company with following descriptions. Just note it down. Just note it down. Now we are creating the ER diagram for a company. Okay. So these are the requirement list. Company has a several departments. First one, each department may have several location. Okay. So while I'm reading, try to analyze the entities. First of all, try to find out the entities, each and every statement. Company has a several departments. Then each department has the several locations. Then departments are identified by the name, department number, locations. So I just read the three statement. Okay. Can you analyze the entities? Which are entities in these three statement? No one? Is it that much tough? Company has a several departments. Which are the nouns? Department is a one of the entity. And departments are identified with the name, department number, locations. A manager control a particular department. Each department is associated with number of projects. Okay, each department is associated. If is there any doubt, if we're not understand anything, then let me know. Employees are identified by the name, ID, address, date of birth of joining. Then, then an employee works in only one department but can work on a several projects. Okay. We also keep the track of the number of hours worked by an employee on a single project, and each employee has a dependent, and dependent has D names, gender, as well as the relationship. So go stepwise. First of all, identity determines the entities from the given problem. First step is was determine the entities. Hmm? Can anyone guess from this problem which are the entities? Yes, it may be a wrong. It's okay. Hello, are you there? Am I audible? If you don't want to unmute, just text me the message. No issue about that. Let me know. Hello. I'm asking one question. Whether the given problem is there, hmm? Can you analyze the which terms are comes under the entity? It may be a wrong, no issue. Just come up and tell me the answer. When I'm asking to, are you clear with the concept? Are you understood? Then then you say yes. And why I'm asking you questions, guys? Just give me answer. These are the somewhat easy concept, not that much hard. Okay, I will point out now. Okay, Aishwarya, department, that's correct. Employee, very good. Thanks for the response. Step one is what? Find out the entities. And step two is find out the add the attributes related to that entities. Hmm? So I just read the problem. Hmm? In that, employee comes under the entity, department is the entity, project is the entity, as well as the dependent is the one of the entity. So there are total four entities are there. You understand the problem? Is there any doubt? Okay, we are designing the diagram ER diagram for our proposed company. Hmm? For that, customer giving us a requirement statement. According to that, we have to design first of all ER diagram. These statements for statement list are over here only. Okay, these are in the format of words. We have to convert into the our technical language. First of all, find out the entities. The employee ID. Attributes of employee entities are the name, ID, address, gender, date of birth, joining date, huh? And ID is primary key for a employee key. Okay. Can you draw a diagram for employee entity? How it's going to look? Employee comes under the in the rectangle format, and the attributes are in the oval format, and these are connected to the employee entity with the lines. Draw this one fast. First of all, draw the diagram for employee entity. Then the I will wait for 2 minutes. Next is the department entity. Attributes of department entries are department number, name, as well as the location, and that primary key. Primary key means key attribute, which uniquely identifies that entity. Okay, we will see the key concept very well in detail next few coming lectures. Here, department number is a primary key for department entity. Then, next, project entity. Attributes of project entities are phone number, name, and location. And dependent entity. Attributes of dependent entities are dependent number, name, gender, and relationship. Okay. So draw the diagram for these four entities, ER diagram, first of all. Completed. Here we are completed our first as well as second step, that is determine the entities and add attributes with related to that entities. Now, third step, relationship identifications. So there are total four entities, right? Employee entity, department entity, project entity, and dependent entity. So first, employee works in a department. Okay. So many employee works in a one department, but one employee cannot work in many department according to the statement. Okay. So employee works in department. So works in comes into the diamond. Okay. Employee works in department. Many employee works in a one department, but one employee ca- cannot work in a many department. So which kind of relationship is it? Cardinality, many employee, one department. And one department, many employees. Which kind of, if employee at left hand side and department is at right hand side, which kind of relationship? One to many or many to one? See, one employee is related with only one department, right? Yes, I won't answer. Employee works in department. Many to one. Is it correct?
One to many.
Yes, it's one to many. Many employee works in one department means one employee related with the one department. Okay, but department has the many employee. Okay, then manager controls a department. Employee works under the manager. Employee works under the manager of the department, and the manager records the date of joining of employee in the department. So mention the relationship. Manager and department relationship is what? Controls. Then department has a many project. One department has a many project, but one project cannot come under many department. Employee works, note down these points, students. Employee works on a project. One employee works on a several project, and number of hours works by employee on a single project is recorded. We are on now identifying the relationship. We are categorizing the relationship. Okay. And employee has a dependent. Okay. So each employee has a dependence. Each dependent is a dependent on only one employee. Okay. That means his parents info, kids info. Okay. Note down these points too. Now, whatever we have discussed just now, the complete ER diagram for the company is represented in this way. Now, first one, draw the entity, represent the entity by the rectangle, that is the employee, department, project, and dependent. Okay, which is shown in the rectangular format. After that, draw the attributes and connect in the oval. Employee has the different kinds of attributes: gender, ID, name, address, date of birth. Hmm, and these are connected with the lines to the employee. Then the we are adding the attributes for the department, that is the department number, name, locations. Okay, and the project, For project number, name and locations. These are the attributes. And dependent name, gender and relationship. These are the attributes. So now over here for employee, which is the key attribute? Which is the key attribute in the diagram? ID, which is underlined. And for department number. And for the dependent, there is a no need of any key attributes because it's a dependent entity. Hmm? There is a why it's dependence, because there is a no specific attribute which is uniquely identifying the dependent. Hmm? So there is a no key attribute is available. Now represent the relationship. Employee works in department. Okay. Manager is a one of the employee. Huh? One of the employee type is manager who works for the department. Okay. We have to keep record of how many hours employees working for the specific projects. So employee works on hours for a specific project, and employee and dependent of. Hmm? Here the total participation should be a there. That's why we are representing this relation by a double line. Okay, is that clear? Just draw this diagram, otherwise take a screenshot. Okay, now move to the next point, diagram issues. Yes, diagram is a general purpose diagram. This is one of the general purpose diagrams. There is a no any hard and fast rule to design any diagram. There is no any hard and fast rules. Okay, according to the knowledge, experience, as well as the way the database designer designs the diagram. Okay, so while if there is a big companies there, then sometimes we are facing these kind of issues. Use of entity set versus attributes. This is one of the issue. Use of entity set versus attributes. Here the choice depends on the structure of the real world enterprise that is being modeled and the semantic association with its attributes. See, for an example, we have an entity set as a students with its attribute. Listen properly. I am explaining the use of entity set versus attribute. Sometimes we are using particular object as an entity set, or sometimes it comes like a attribute. So, suppose a student is an entity with its attributes ID as well as the name. Now we can say that student ID is an entity with that attributes like ID with student class as well as the student section. First of all, student is an entity, and in that ID and names are attributes. In next scenario, ID is an entity with its attributes students class and student section. Are you clearing? There are two scenarios. In first scenario, student is an entity and ID and names are attribute of that entities. But in next scenario, ID is an entity. Means ID is over here may work as a entity set or attribute, but choose wisely as well as it depends on the structure of the real worlds. Okay, so this is the one of the design issue, use of entity set versus attributes. Okay, the next is the use of entity set versus the relationship set. Possible guidelines is to be designates a relationship set to a describe an action that occurs between entities. Say sometimes it's hard to decide that object can be represented by the entity set or relationship set. Hmm? It's sometimes difficult whether it define object may be a entity set or it may be a relationship set. So at that time, user needs to designate a relationship for describing an action that occurs in between the entities. We should categorize wisely. According to the action needed, we have to define whether it's entity sets or relationship set. Okay. Use of third issue is what? Use of binary versus entry relationship set. Hmm? In most cases, the relationship described in ER diagram are a binary. Hmm. The end-ray relationship can make ER design complex. If there is an end-ray relationship, it may design complex, and we can convert it into the end-ray relationship to the multiple binary relationship. This may sound sometimes confusing. Yes, database management system has the binary relationship at most of the time, but if there is a occasionally end relationship is there, we can represent that one, but it creates somewhat complex design, it may create confusion. uh, we have to convert that relationship into the binary one. Okay, for example, mother is a parent, who is parenting to their child. Father is also parent who is parenting their child. So mother, father, as well as just child. There is a relationship of a parenting. Now we have to convert this relationship into the binary. This is the ternary or entry relationship. Mother, father, as three entities are present now. Mother, father, as well as the child. How we can convert into the binary? Mother and father, we have to club into the one entity, that is the parent. Like that we have to convert. Okay. Then placing relationship attributes, the cardinality ratio can be become a effective measure in the placement of the relationship attribute. So it is better to associate attributes one to one or one to many relationship sets with the any participating entity sets instead of any relationships. Mainly convert any relationship one to or one to many. Okay, these are the four ER designs issue. Note it down.